So it's my pleasure to introduce Andre Nell, who's the director of the Center for Environmental Implications of Nanotechnology, which is a multi-campus center funded by the National Science Foundation and the EPA. And he has really been also a visionary in this area, bringing together a diverse group of scientists and engineers to approach this problem with a very novel interdisciplinary approach. And I have to say personally, I'm very thankful to him for supporting our efforts within the education and outreach group to reach out, for instance, to government agencies, regulators, and industry, which I think is an important component of our being able to take the science from the center and use it to inform policy and decision making. So, Andre, welcome.
Thank you, Hillary. It's a pleasure for me to welcome everybody to CNSI, which is one of the premier academic institutes for the conduct of nanoscience in the state of California and nationally. It's a 180,000 square foot facility that's entirely devoted to the topic of nanotechnology. It's a pleasure for me to welcome our friend from the Department of Toxic Substances Control, Maziar. Pleasure to have you here. And I wanted to just say a few words about what our efforts are comprised of in the UC Center for the Environmental Impact of Nanotechnology. So in the one slide that I want to show you, in terms of what Maziar has already said, is we've begun an integrated effort that is focused on trying to elucidate what it is about nanomaterials and the safe implementation in the environment. And in order to perform that exercise correctly, the ingredients are, of course, nanomaterials and their unique properties and how those properties relate to different environmental life forms in the water, freshwater, seawater, terrestrial. And in order to perform this exercise, we have a multidisciplinary group, which is comprised, if you look at the top left-hand side, of some experts of nanomaterial science who are deliberately making materials for us, the commonest type of nanomaterials which at the moment are being commercialized in deliberate variations of shape, size, and all the nanoscale features that we have to consider in terms of safety. And the reason why we're performing that exercise is to be able to relate nanomaterial structure and physical chemical characteristics to what takes place when these materials meet life forms in the environment. As additional part of that exercise, we then study how those materials can be transported, their fate and transport in the environment. What is it about a material that will allow it, for instance, to get access to aqueous environments? How may the material get there? What can we do to prevent the spread of the material by making use of the properties? And then in the middle part of the equation, concurrent with that exercise, we study the material properties first at a biological level where we can make a lot of observations, namely cells and embryos, and at molecular level where in test tubes you can collect huge volumes of data in order to understand what it is about the properties of materials. We then introduce this knowledge into a deliberate series of observations, of which Trish Holden will inform you today, to do toxicity testing in freshwater, seawater, and terrestrial organisms at different trophic levels in the environment in order to see if there's any harm that occur and to observe what may happen, but also with a view to gaining important information how to prevent that harm by redesigning the materials. The data that is being generated is called a predictive exercise, in which we try to make observations at molecular and cellular level that informs outcome at organism level. The data is also used then for multimedia analysis in different environments. The data are integrated into computerized decision-making tools or in silico methods, and that includes the new field of nanoinformatics, where we not only look at these interrelationships but try to model and predict them. So on the top right-hand side, you see our considerable efforts in developing decision-making tools for data integration, pattern recognition, machine learning, and then all of the information is fed forward in ultimately providing hazard ranking, risk profiling, exposure modeling, and understanding what it is about the properties of materials. So since its inception 2 years ago, the CEIN has had a national impact as well as impact on local state level. I'm glad to talk a little bit about the efforts that we've interacted at state level extensively with the Department of Toxic Substances Control to talk about the knowledge generation, to talk about obtaining information about the products that are out there, material properties. We have helped at national level also to advise the Nanotechnology Initiative, the National Nanotechnology Initiative, about important issues about decision-making on nano-EHS issues. We've had a workshop on legislative and policy issues that was led by Tim Malloy, who will also speak on today's conference. We have participated, several members of our center, in a new future vision for nanotechnology that has been written for the next decade, in which we make predictions of what will happen in nanotechnology at large, including nano-EHS, and that will come out in the form of a book that will be published by NSF later in the year. We've also participated in several national workshops on risk management, regulatory policy, and will also participate in a workshop on nanoinformatics, because there is also a huge need for that. So with a few words of introduction about what CEIN is, I'm turning back to Hillary to introduce our first speaker. Thank you, Hillary.